NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we solve a special system of equations using a single helper variable t. The key idea is to set the three equal fractions to a common value and then use the second equation to solve for t. Here is the general system. The top line says three fractions are equal. The bottom line relates x, y, and z with alpha, beta, gamma, and L. Because these three expressions are equal, we call their common value t. We write t equals the first fraction equals the second equals the third. Now solve each equality for the variable inside. From t equals the first fraction, we get x equals mt minus b over a. From the second, we get y equals nt minus d over c. From the third, we get z equals k t minus f over e. Substitute these expressions into the second line. That turns the system into one equation in t only. Alpha I over mt minus b plus beta c over nt minus d plus gamma e over kt minus f equals L. Solve this equation for t, then back substitute to get x, y, and z. Let us practice with a concrete example that gives a clean solution. Choose a equals 2. Set the common value to t again. Then x equals t minus 1 all over 2, y equals t plus 1, and z equals t. Substitute into the second equation to get 2 over t minus 1 plus 1 over t plus 1 plus 1 over t equals 17 over 6. Multiply through and solve. A convenient root is t equals 2. Therefore, x equals 1/2, y equals 3, and z equals 2. Recap. Step 1. Set the three equal fractions to t. Step 2. Solve for x, y, and z in terms of t. Step 3. Substitute into the second equation to solve for t. Step 4. Back substitute to find x, y, and z. This t method collapses a three-variable system into one equation. Use it whenever several expressions are stated to be equal. Step 1. Because each product equals 3, we can solve each variable directly. From a x equals 3, we get x equals 3 over a. From b y equals 3, we get y equals 3 over b. From c z equals 3, we get z equals 3 over c. Step 2. We now bring back the second relation, the sum of reciprocals. Step 3. Substitute x equals 3 over a, y equals 3 over b, and z equals 3 over c. Step 4. Taking the reciprocal of 3 over a gives a over 3, and similarly for the others. So we obtain a over 3 plus b over 3 plus c over 3 equals 5. Step 5. Multiply both sides by 3 to isolate a plus b plus c. This gives a plus b plus c equals 15. Therefore, using the common value method in the exact step order, the sum of plus b plus c equals in the exact step order. The sum of plus b plus c equals 15. In this example, we will solve a symmetric system using a clean substitution strategy. Let's place the problem on the screen first. Step 1. Because alpha x equals b, y equals c, z, set their common value equal to t. Then solve each mini-equation for x, y, and z in terms of t. Step 2. Bring back the second equation. Now substitute x, y, and z from the t expressions. Simplify carefully to collect over t. Then write it as one fraction. Step 3. Solve for t by cross-multiplying. Step 4. Substitute this value of t into x equals t over alpha, y equals t over b, and z equals t over c. This yields the final closed forms. Recap. We exploited the symmetry by setting the common value to t, expressed x, y, and z in terms of t, used the reciprocal sum to solve for t, and substituted back to obtain each variable explicitly. Used the reciprocal sum to solve for t, and substituted back to obtain each variable explicitly. Example. We will solve a system that mixes a ratio condition and a reciprocal sum. Given x over 2 equals y over 3 equals z over 4, and 1 over x plus 1 over y plus 1 over z equals 13 over 24. We want x plus y plus z. Step 1. When three fractions are equal, introduce a common parameter. Let them all be equal to t. Then x equals 2t, y equals 3t, and z equals 4t. To build intuition, We will also draw bars of lengths 2t, 3t, and 4t. Step 2. Substitute the expressions into the reciprocal sum. 1 over 2t plus 1 over 3t plus 1 over 4t equals 13 over 24. Factor 1 over t out. The parenthesis is 1/2 plus 1/3 plus 1/4, which equals 13 over 12. Therefore, 1 over t times 13 over 12 equals 13 over 24. Solving for t gives t equals 2. Step 3. Now compute the requested sum. X plus y plus z equals 2t plus 3t plus 4t, which is 9t. With t equal to 2, the sum is 18. Recap. We introduced a common ratio t for the equal fractions, substituted into the reciprocal sum to solve t equals 2, and then added 2t plus 3t plus 4t to obtain 18. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.